5.1. This is called estimating with finite sums. So let's consider finding the area under the curve of y is equal to 1 minus x squared in the first quadrant. Alright, so what we're really looking at is we know that we have our function right here, and we know that 1 minus x squared is a parabola. You know, it's got a vertex of 0, 1 because it's shifted up 1, and also it's flipped over the x-axis. So we have is a parabola that looks like, it looks like this. Now, the question comes to what's the area of the curve in the first quadrant? So I don't need the entire function. The only part I really need is just the part that's in the first quadrant. So I'm going to erase that part of it, and I don't need this part right here. I'm looking for just this part that's in the first quadrant. So I'm really only looking at this curve. So this happens to be this is your y is equal to 1 minus x squared. So what we're going to do is we're going to use rectangles to estimate this. So what I'm going to look at is, if I start with this curve, if I want to find the area underneath this curve, so I'm looking at this area right here, what we can do is, because it doesn't need to be that perfect, but I want to find this area underneath the curve. What I want to do is I can do this using rectangles, and so I'm going to start with that curve again. I know it looks like this. And kind of the question comes down to if I want to, I could choose a rectangle right here. So let's cut this thing into 2 rectangles. So this is a little fat, but let's cut this thing into 2 rectangles. So I have this rectangle right here, and then this rectangle right here. Now, if you're looking at the area, wow, one of those big copters from the those big military copters. I think was shaking my house. All right, so if I'm looking at the area now, I can tell that the area in these rectangles is, it's not the area under the green. It's not exactly the same thing as that, but I know that at least this is going to be some kind of an estimation. That this will give me some kind of the area that I'm looking at right here. It's not perfect though. So well, what we could do also is, instead of using 2 rectangles, because what I notice is it's too big because I have a little bit above and a little bit above right here, so it's too big. So what happens if I use more rectangles? So what I'm going to do is I'm going to partition this into 4 slices. So 1, 2, 3, 4. So 4 slices. Then if I use these rectangles, so here, I don't want that to be so big. So something like 1 rectangle, then this would be another rectangle, and then another rectangle, and then your last rectangle. So if I'm looking at this one right here, now I know that that the area now, to me, is looking better. I'm not sure if you guys see the same thing that I'm looking at, but what I noticed, even just looking right here, this square right here, which is here, is no longer in here. So this is definitely a better estimation. So we could use even more. We could even double it, do 8 rectangles or 16 rectangles, and so on. What I can tell you is that the more rectangles, the better we get. So just for purposes of time, what we're going to do is we're going to do 2 rectangles and 4 rectangles, and then we're going to see this estimation. So this is going to be our example. So let's estimate using two rectangles and left endpoints. Now, what I mean by this left endpoints is when I'm looking at this when I'm looking at that function. We're going to use two rectangles, so I'm going to cut this into half. Now, what I mean by left endpoints is this would be the left side of that rectangle, of the first rectangle over here, and this is going to be the left side of that second rectangle. So when I set up these rectangles, I go up here, and if I'm going to use a left endpoint, I'm going to stop when the left side of that rectangle hits that, and I'm going to move it over from here. So the endpoint of this rectangle, the left part of the rectangle, is intersecting the curve. And then for this one, the next rectangle, I'm going to use the left side of this rectangle is going to intersect the curve, and this is going to be that one. So when I want to estimate this, we're going to find the area of these two rectangles. So what we have here is really there's three lines here, right? I have this is going to be x equals 0, this is x equals 1, and this is x is equal to 2. But if I'm using left endpoints, I'm just going to use 0 first and then 1 next. So let's determine the width of each one of these rectangles. Okay, well, why am I doing that? Well, in order to find the area of each one of these rectangles, I need to know what's the width of the rectangle and what's the height of the rectangle, because it's going to be, length times width or length times height, horizontal times vertical lengths. And same thing here. I need to find the length and the width of this, or the width and the height, I think is what we're going to use for our words. So what we need is to determine the width and height of each rectangle. All right, so how do we find the width? Let's start there. So it's not necessary that we make the width always the same. I could use a really wide box here and a really small box here. But for to make this easier, we're always just going to make the width exactly the same. So the way you're going to find the width is you're going to do it's a formula. It's b minus a over n, where this domain restriction, where we're starting, where a is going to be the left part of the interval. So calculating an area over the interval a to b and n rectangles. So we're going to use this formula when we're over the interval from a to b. So in this case, the interval is going to be from 0 to 2. So this is going to be your a and this is going to be your b. So it's going to be equal to 2 minus 0. And then since we're using two rectangles, it's going to be over 2. Now you can tell the width of each one of these is equal to 1. I did that on purpose because I want it to be simple at first. So the width is equal to 1. But for the more complicated ones, you're going to want to do b minus a over n. Now, in order to find the height of these things, in order to find our heights, well, the heights are the evaluation of the function at our left endpoints. So the first height at 0. The way we find this is this is going to be equal to the height of this thing at x is equal to 0 is actually going to be the function at 0. So this will be equal to f of 0, which is 1 minus 0 squared. Because remember, this f of x, which is equal to y, which is equal to 1 minus x squared. So if you want to find the height, you're going to need the function. You're going to need that green function. So this is equal to 1. And we also have to find the height at, well, the next left endpoint is going to be equal to 1. So this is going to be equal to f of 1, which is equal to 1 minus 1. Oh, I'm wrong here. Grumpy about this. Let me clean this up. I'm just a little off. I took for granted that there's going to be 1 and then 2. It's not. If you're looking at 1 minus x squared, this thing crosses the x-axis when y is equal to 0. So if this is equal to 0, you're going to solve for x, and it's going to give you plus or minus 2, because this factors to 1 minus x times 1 plus x. So technically that point is equal to that's equal to 1. So then this is going to be equal to a half. So fixing this width equation is going to be b minus a all over 2, so this is going to be a half. So now the heights, we have the height of 0, which is the first endpoint, so this is equal to f of 0, which is equal to 1 minus 0 squared, which is equal to 1. And the second height, which would be h at a half, is going to be equal to f at a half, which is going to be equal to 1 minus 1/2 squared. So 1 minus a fourth is equal to 3/4. So now I can find the area. There it is. So I want to clean this up. I know the width is equal to 1/2, but what we're going to call this is we're going to call this the change in x. So when I want to find the area of this function, your area is going to be equal to, it's going to be the height of the first times the width of the first plus the height of the second one times the width of the second one. And we can kind of clean this up a little bit. I know that this is going to be, your height function happens to be h of 0 times your change in x plus h of h of a half times your change in x, which means you could really factor out your change in x and just sum up the heights and then multiply by the width. So plus h of a half times your change in x. Now it's up to you. You're welcome to just use this formula and plug those numbers in. Because what you know is going to happen here is, h1 is 1 and the width is a half, plus h2 was 3/4 times the width is equal to a half. So there's nothing wrong with using that formula, but this is slightly more sophisticated. But what I'm trying to eventually show you is what kind of happens here. So this is going to be the same thing as f of 0 plus f of a half times your change in x. So this is going to be equal to 1 plus 3/4 times a half. So we get 1 3/4, so 7/4 times 1/2, which is going to be equal to 7/8. And when you add these things up as well, you're going to get, like I said, this is the same thing. This is 1/2, which is 4/8, plus 3/8, so we get 7/8. So that's about the area underneath the curve. I know it's so how about 4 rectangles? All right, so 4 rectangles using left endpoints. So let's start out with the graph. So it's going to be the exact same function I'm talking about. So it's going to be 1 minus x squared, so it's going to look like this. Now using 4 points, I know I'm going to cut this in half twice, so in half, and that in half, and that in half. So we know this goes from 0 to 1, and let's figure out these values. I know it's not complicated, but what I'm going to do is I'm going to talk about your change in x. So your width, which is equal to your change in x, is going to be equal to b minus a over n. Now, since I want to use 4 rectangles here, using left endpoints, so the left endpoint of this one, left endpoint of this one, left endpoint of this one. Oh, I'll do that again. Picture could be a little better. Oh well. So if we're using 4 rectangles, so now I know that that your b is still 1 minus a, which is 0, all over n, which is 4. We knew that this is going to be equal to a fourth. So when we set this up, this right here is going to be, the first distance is going to be a fourth. This is going to be 2 times a fourth, so 2 fourths. This is going to be 3 times a fourth, which is 3 fourths, and this is right here is going to be 4 fourths. Now I know that's the same thing as 1/2, so that's probably what we're going to use. Now I also have to find, the heights of each one of these things. So I'm not going to go through all the work on finding the heights. We're just going to kind of know that the heights happen here. So I know that my area is going to be equal to, it's add up all the heights and do the change in x. So it's going to be equal to f of, well, I'm going to start labeling these things. This is going to be equal to x1, this is x2, this is x3, this is x4. So this is going to be x1 plus f of x2 plus f of x3 plus f of x4 times your change in x. So that's what we're looking at. So when I have this is going to be the height of the first one, which is going to be f of 0, plus the height of the second one, which is going to be equal to f of a fourth, plus the height of the next one, which is f of 2 fourths, which is a half, plus the height of the next one, which is f of 3 fourths. And then we're going to multiply them all by the change in x because it's 1/4. So really it's just, just base times width over and over and over again, or base times height over and over and over again. All right, so when we set this up, f of 0 is, well, plugging in 0, we know that this is 1 minus 0 squared plus, this is going to be 1 minus a fourth squared. That's not the way you write that. There we go, close. Plus this is going to be 1 minus a half squared plus 1 minus 3/4 squared. And then this is all going to be multiplied by a quarter. So simplifying, this is 1 plus 1 minus a 16th is going to be 15 over 16 plus 1 minus a quarter is going to be 3 over 4 plus this is 1 minus 9 over 16, so this is going to be 7 over 16, all times a quarter. So turn them all into 16 over 16 plus 15 over 16 plus 12 over 16 plus 7 over 16 multiplied by 1 over 4, 31, 43, 50, yeah, 50. So this is equal to 50 over 16 multiplied by a fourth. So this is equal to 50 over 64. Now I know that this is definitely better. It's better because I'm not adding like these extra pieces here and here. So what I want to do now is I want to use right endpoints. So as opposed to using left endpoints, let's use right endpoints. So I'm just going to go straight to 4 rectangles using right endpoints. I should say estimate the area would be more accurate because it's not really calculating, we're going to estimate. and 4 rectangles. Oh my gosh. I bet you guys can hear SpongeBob. Let me go turn that down. Alright, so doing a picture. It's not necessary to do a picture, but it definitely helps to visualize this. So we have the same function, 1 minus x squared. Now we're going to use 4 rectangles using left endpoints. So that means I'm going to cut this axis into 4 slices. And we already know that the change in x, if you're going to use 4 rectangles, since this is 1 and this is 0, is going to be 1 minus 0 over 4, so this is still a fourth. So 1 over 4, 2 over 4, 3 over 4, 4 over 4. And now when we're doing the rectangles, we're going to use right endpoints. So that means instead of starting at 0, I'm going to take this rectangle straight up until I hit the curve at the right endpoint. So this one. This until I hit the curve. Bring this one up till I hit the curve. And then this one, when you hit the curve, is just going to be right here. So that's got a height of 0. So now I know my area is going to equal, well, the x values I'm choosing, x1, x2, x3, x4 is shifted right because I'm using right endpoints instead. So, you know, the area is going to be equal to, well, f of x1 plus f of x2 plus f of x3 plus f of x4 multiplied by my change in x. So this is going to be equal to f of a fourth plus f of a half plus f of 3/4 plus f of 1, and this is all going to be multiplied by change in x, which is a quarter. All right, so f of a fourth, we've already calculated it. This thing was 15 over 16. A half was 3 over 4. We did that in the last exercise. 3 over 4 was 7 over 16. And when you plug in 1 minus 1 squared is 0. So this one's going to give us height of 0, all multiplied by a quarter. So adding these things up is going to give me, let's see, 15 over 16 plus 12 over 16 plus 7 over 16 multiplied by a fourth, 15, 17, 34. So this is equal to 34 over 16 multiplied by a quarter. So this is equal to 34 over 64. Oop, that's not 64. Over 64, which also you can write as 17 over 32. All right, let's get some approximations here. This is about 0.53125, and the last one approximated to, let's go back to the last one. Where are you? Right there. The last one was about 0.672. You can tell that this was a little bigger and the other one is a little smaller. Now, we're going to give a definition in a second here when it calls for a like an upper sum and then a lower sum. This is what you consider an upper sum. This is the upper sum. It's the upper sum because it's an overestimate. It's, you know, it's bigger. All these boxes are bigger than the curve. Now the other one is what we consider a lower sum. This is our lower sum. And what you could do, if you, because you know that this is an underestimation and the other one's an overestimation, is you could actually average these two numbers and it would give you a better estimate of this actual curve. So you could really add your upper and lower together and divide by 2 and get an even better estimation. Now they do also talk about this book, a middle sum. And I'm just going to draw it for you, but we're not going to calculate it. Like, these things take long enough, and really the upper and lower are good enough for our needs. So what you could do instead of 1, 2, So what you could take your box up to is, instead of using the left endpoint, you could use the middle. So then your box could be a little above and a little below every single time. And what this middle sum would do for you is, it's actually a better estimation is why they're having you calculate middle sums. This would be a better estimation of what the actual curve is without having to average the upper and the lower. But it's not going to give you much of a different answer than averaging the upper and the lower sums. So even though this is considered a middle sum, we're not gonna calculate it. So the way you do that is you'd have to do half points, right? So you'd have to plug these values into x. So this would be 1 8, 2 8. This would be 3 8s, 4 8s. This would be 5 8s, and then 6 8s. This would be 7 8s. So it would be f of an eighth plus f of 3 8s plus f of 5 8s plus f of 7 8s. I guess I've already done it all over, multiplied by the change in x. And that's how you calculate it. So it's really no different than what we did before. All right, so since we went this far, I might as well finish it. So we know that this is going to be equal to, so our area, the approximation for our area is going to be, let's see, 1 minus an eighth squared. So this is going to be 1 minus 64 plus 1 minus 3 8 squared. So this would be 9 over 64 plus 1 minus 5 8 squared. So 25 over 64. And then plus 1 minus 7 8 squared, so 49 over 64, multiplied by a quarter. So when we calculate this, let's see, 64 minus this is 63 over 64. 64 minus 9 is going to be 55 over 64. 64 minus 25, 29, let's see. That's not right. 64 minus 25 is going to be 39 over 64. Plus 64 minus 49, 15 over 64. All multiplied by a quarter. So 63 plus 55 plus 39 plus 15 is going to be 172 over 64 multiplied by 4 is going to be equal to 172 all over 64 times 4 is going to equal 256. So this is about, should be close to what we got before, yep, 0.6718. There, 0.671875. So, kind of what we expected, between the upper and the lower sum. Now, I did want to describe what you guys have to do if I was asking you guys to find an upper or lower sum of, I don't know, maybe something that looks like this. Maybe like y is equal to 9 minus x squared. And I want, the entire area, just not in the first quadrant. So what I know is this will be 9, and it would look something like this. So here and then here. Now, the thing we have to be careful of is your left endpoints and your right endpoints aren't always necessarily going to be your upper and your lower sum. The upper sum means the boxes have to always be above, and your lower sum means the boxes always have to be below. So if I was going to calculate, say, an upper sum here, let's do an upper sum. What I'm going to do is over here, since it's increasing, I'm going to be using right endpoints, and over here, since it is decreasing, I'm going to be using left endpoints. So it's not very symmetric and it's bothering me. So I'm gonna do this 4 rectangles. So we know it's going to be 1, 2, 3, 4. And I know it's going to come up to here, and then this is already drawn, and then here. Now I want these boxes to always be above, so in this particular case I can't use a left endpoint because the box would be below. I'd have to use a right endpoint and do this. Same thing here, since it's increasing, and if I want to do an upper sum, I'm going to have to do the right endpoint because the right side of the curve is above the left side. That's what it means to be increasing. As x gets bigger, y gets bigger. Now, this is decreasing, so as x gets bigger, y gets smaller. So for an upper sum, I'd have to use the left endpoints for this side. And pretend it's symmetric, so left endpoints for this side. So what I know is this is 3 minus x times 3 plus x. So it's got zeros at -3 and +3. So if I want to find your change in x, your change in x is going to be equal to b minus a, so 3 minus a -3. This is your a, and this is still your b. b minus a over n, so this would be over 4. So what I have is 6 over 4, which is equal to 3 over 2. Now, if I want to find, the values of the box, that 3 over 2. Yeah, that makes sense. Okay, so this is a little more complicated because if I'm going to find this point right here, I know that this width is 3 over 2. So let's make this really easy. Since this is 0, this is clearly 3 over 2, and this would be, you'd double it to get 6 over 2, which would be equal to 3. So if this is 3 over 2 and 3, this has got to be -3 over 2. So my area is going to be equal to, well, remember what point we're using. So this is going to be, for the first triangle, this is going to be x1. For the second triangle, this is going to be x2 and x3, because I used the right endpoint first and left endpoint next. And then the last one, this is going to be your x4 right here. So what we have is f of x1, which is -3/2, plus f of x2 plus f of x3, which happens to be the same point, plus f of x4, which is 3/2, all times 3 over 2. So this is going to be equal to, well, ugly. That's fine. So we're going to have, I'll do it over here so I have some more room. So this is going to be equal to 9 minus, when you square a number, it's always going to be positive. So this is going to be 9 over 4 plus 9 minus, I can do that one, 0 squared, so it's going to be just going to be 9 minus 9 minus 0 squared, which is going to be 0 as well. Plus, and then plus 9 minus, when I square that, it's going to be 9 over 4 again. And we can tell if I knew one side, I knew the other, so I don't really have to do everything twice. So 3 over 2. So this is 36 over 4, top and bottom by 4. So 36 minus 9 is going to be 27 over 4. So this is equal to 27 over 4 plus 9 plus 9 plus, again, 27 over 4 multiplied by 3 over 2. So how many 4? So 36, 27 plus 36. I do it again. So I got 126 all over 4 multiplied by 3/2. So times 3. So this is 378 all over 8. Which is about 47.25. Which is about 47.25. Alright. Remember, if you did a lower sum, if I did a lower sum, like these would be the box. Oh, that's a hard one to see. So if you did a lower sum, your boxes would look like, these would be your boxes now. So, you'd find this instead. So it's nice about doing a lower sum, I only have to use these points, right? So heck, we can just do it, it's simple. So your lower sum, your area would equal, this is clearly 0, so I just have to find this box, and we already found that box. That box right here is this 27, so it's going to be 0 plus 27 over 4 plus another 27 over 4 plus this box is going to be equal to 0 times 3 halves. So 27 plus 27 should be 54 divided by 4. So this is 54 over 4, 3 halves. That's 3, 162 over 8. So this is about 20.25. So, you know, they're gross overestimation and underestimation, but, you know, if you average those two, you'd probably get a pretty good value for this. And that's what I have for 5.1. It's not much.